Algebra 1 students, in this video today we're going to be reviewing what a linear equation is. We are going to be learning how to test ordered pairs to see if they are a solution to a linear equation, and then we're going to find solutions to linear equations. Now, if you're thinking like I think you might be thinking, I know that we've already learned how to solve linear equations. I understand that, okay, but this will be a little different, so hang with me. Alright, here we go. Please copy down your heading, and please copy down the lesson number, and please copy down today's date. Alright, linear equations and the coordinate plane, lesson 4.2. Now, we've studied already this year linear equations, and in lesson 4.1 we studied the coordinate plane. Well, now we're going to tie these two things together. Okay, we're going to tie these two things together. First, let's review what a linear equation is. You can copy this down or you can sit and watch, whatever you choose to do. This would be a linear equation. Why? Because the variable has a power of 1. This would be a linear equation. You say it would, Mr. Earhart. There's an x and a y. I know, but the power of x is 1, and the power of y is 1. Now, if I would have had a squared right here, now this is no longer a linear equation. We call this a quadratic equation. Now, do not write that down. We're going to study those later this year, okay? But my point is when the variables have a power of 1, it's a linear equation. This would be a linear equation right here. A plus 6 equals b, because your power of a is 1 and your power of b is 1. If there was a 2 right here with the 6, that's okay. It's still a linear equation. The variables, the letters, have to have a power of 1 in order for the equation to be linear. Do you understand? Now I want to explain thoroughly what a solution to a linear equation looks like. Okay? First, though, I want to give you a definition of what a solution to a linear equation is. I want you to write down this definition. Now, like always, I move on, so pause the video and copy it down. Solution of a linear equation. It is an ordered pair that satisfies a given, that should be given linear equation. It's an ordered pair that satisfies a given linear equation. I'm going to move on. Please copy that in your notes. Now let me give you an example that might make the previous definition a little easier to understand. Please copy down this example. Alright? Would you not agree? Copy this in your notes, please, right here. Would you not agree with me that that is a linear equation? I hope you would agree with me on that. What is the power of the y? 1. What's the power of the x, or the exponent of the x? 1. So we have a linear equation, okay? So here's an ordered pair. Now, we studied these in lesson 4.1. Remember, this is the x value, or your left-right value. This is your y value, or your up-down value, okay? In an ordered pair, the x value always comes first, then the y value. So this is my x, this is my y. Where the y is, I'm going to put what? -4. Where the x is right here, I'm going to put a 1. Okay, now let's see what happens. What's a -4 and a +5? Well, it's a +1. What's 3 times 1? 3 minus 2, or -2. 1. Did I get out a true or a false statement? 1 equals 1. Well, that's true. So did this ordered pair satisfy the linear equation? Yes, it did. So is this ordered pair a solution to this equation? Yes, it is. So do you see now what this definition means? When an ordered pair satisfies a linear equation, it's a solution. By the way, there can be more than one answer, just so you know. Let's try this one here. Where the y is, I'm going to put a -10. And where the x is, I'm going to put a -2. -10 positive 5, you owe me $10. You pay out 5, you owe me 5. 3 times negative 2 is negative 6. Negative 2, you owe me 6. You owe me 2 more. You owe me 8. Negative 5 equals negative 8. Is that true or false? That's false. So this ordered pair does not satisfy the linear equation. Thus, it is not a solution. By the way, I said this about a minute ago. There can be more than one solution to these, okay? There can definitely be more than one solution to these. For example, this ordered pair right here, this ordered pair right here is a solution. Real quick, put a 5 for the y. What's 5 plus 5? 10. Put a 4 for the x. 3 times 4 is 12 minus 2 is 10. 10 equals 10. So you can have more than one answer, okay? Alright. So for the third and final time, an ordered pair that satisfies a given linear equation is a solution to a linear equation. I haven't given you an example of a solution to a linear equation. Let's practice a couple of these problems where you test an ordered pair to see if it satisfies a linear equation. Now, you might find this a little boring, so you can work ahead if you want to, okay? Let's start off first of all with this problem right here. Here's my linear equation. Let's see if this is a solution, okay? X is my 1, y is my 2. So I'll put a 1 right here. Plus 3 times 2. And that's false. 3, don't forget to multiply first. 3 times 2 is 6 plus 1 is 7. 7 equals 6. That's false. So this ordered pair right here is not a solution. Okay, let's try this one. X is negative 3, y is 3. Negative 3. 3 times 3. Well, negative 3. 3 times 3 is positive 9. You have $9. You owe me 3. Pay it off and you're left with 6. 6 equals 6. Yes. This is one of the solutions to this linear equation. There are more, but that's one of them. So no, yes. Alright, let's try another one. You can work ahead or watch me. It's totally up to you, okay? Excuse me for a second. Alright, here we go. Now, here's my x, here's my y. Let's see if this ordered pair is a solution to this equation. Where the y is, I'm going to put a negative 6. Where the x is, I'm going to put a negative 1. And here we go. 4 times negative 1 is negative 4. Bring down your negative 1. Negative 4, negative 1. You owe me 4, you owe me 1. You owe me 5. No, that is false. That does not work. So this ordered pair is not a solution. Let's try the next one. 5 is my x. 19 is my y. And let's see what happens. 19 equals 4 times 5 is 20 minus 1 is 19. Check. Yes. This ordered pair is a solution. Okay. Guys, this is really simple stuff. Now listen. If we continue to use this same thought process where an ordered pair has to satisfy the linear equation, if we continue to use this same thought process, to be honest with you, it really shouldn't be too difficult to find ordered pairs that are solutions of a linear equation. In other words, up here, yes or no, did you find these ordered pairs? No, not at all. I gave them to you. Now, yes, you tested them, but you did not find them on your own. So let's take this thought process a step further. What if I give you a linear equation like this? And by the way, that should be solutions plural. What if I gave you a problem like this and I said, find 3 solutions? What would you do? Well, copy this down, please. Copy this down, and let's work this out together, okay? 2x negative 6y equals 5. Let's find 3 solutions. Now, students, if you'll listen carefully, I will teach you how to do this. What you do is you pick a number for x. Now, if you want to pick something crazy like 1,569, that's fine. I don't recommend that, okay? I recommend small numbers, maybe negative 3, or positive 3, or 2, or negative 2, or 0, or 5, or 6, something small like that, okay? So let's try negative 3. It doesn't matter what number you pick. I'm going to put negative 3 in for x. Got it? Where did I get that? I just picked it. You can pick any number you want. Any number, Mr. Earhart? Yes, any number. Now pick up your negative 3 and put it right here for x. And do you not see what we can do now? We can solve for y, and we'll know what y is. Okay? So, 2 times negative, this is a good old-fashioned linear equation. We learned how to solve these. First, simplify both sides. So on the left side, we simplified 2 times negative 3, negative 6. Next, eliminate fractions. There are none. Next, move your terms around. So your negative 6 comes over here and becomes a positive 6. Next, simplify both sides. Next, divide both sides by your coefficient, so negative 6. A positive divided by a negative is negative 11. 6 is 11, 6. Or you can put 1 and 5, 6, either way. So there you go. So Mr. Earhart, are you telling me that this ordered pair right here, is a solution to this? Yes, I am. This ordered pair is a solution to this linear equation. Now students, we're trying to find 3 solutions. Let's pick another number. Let's try a positive number, like a positive 2. That'd be easy, a positive 2. Remember, you can pick anything you want for x. Got it. 2 times 2 is 4. Negative 6y equals 5. Bring the 4 over, make it a negative 4. And now we're left with negative 6y equals positive 1. Divide by negative 6. Divide by negative 6. And y equals a positive divided by a negative is negative 1/6. So are you telling me, Mr. Earhart, this is a solution? Yes, both of these. We're not going to take time to do it to prove it, but if you were to take this ordered pair and substitute it in, you would get out a true statement. If you were to take this ordered pair and substitute it in like we did up here, you would get out a true statement. Okay? Alright, let's try one more. Let's try something really easy like 0, okay? 0 is pretty easy. Here's the x, put a 0. And now let's solve our linear equation. Step 1, simplify both sides. This side cannot be simplified over here. We have 2 times 0. Step 2, eliminate fractions. I don't see any. Step 3, move your terms around. Well, there's really no need to move a 0. It's just gone. Next, simplify both sides. We can't. And then divide both sides by your coefficient. So y equals a negative 5/6. It's negative because you have a positive. Divided by a negative is negative. Negative 5/6. And there you go. Okay. Now, guys, that's really pretty simple. So you can work ahead, or you can watch me. It's up to you. Okay, let's do one more. Let's try a negative 1. Okay, you can work ahead or watch me. Let's find 3 solutions to this. So where the x is, I'm going to try a negative 1. Here's the x. I put a negative 1. Where did I get this negative 1? I just picked it. Okay. Negative times a negative is positive. You have $2. You owe me 6. You pay off as much as you can. You still owe me 4 more. So negative 4. So this ordered pair, if you were to substitute it in, it would give you out a true statement. Alright. Let's try another number. Let's try something a little crazy. Let's try 35. Alright. You can use any number you want. 35. So negative 2, parentheses 35. You can work ahead or watch me. It's up to you. You can even pause the video, work it out on your own, and then check your answer. Alright. Negative times a positive is negative. It'd be a 72 times 35. You owe me 7. You owe me 6 more. So now you 6 more. So now you owe me $76. So negative 76. This ordered pair here satisfies the linear system. Alright. And then lastly, let's try a negative 5. Again, I'm just picking these numbers at random, okay? Negative times a negative is positive 10. You have $10. You owe me 6. Pay off your debt, and you have 4 to the good. Positive 4. Okay? And trust me, if you let's do this really quick, okay? Put a negative 1 in for x right here. Negative 2 times a negative 1 is 2. 2 minus 6 is negative 4. And look what you're supposed to get. Negative 4. Put a 35 in for x. Negative 2 times 35 is negative 70. Negative 70 and negative 6 is negative 76. And look what you're supposed to get. Negative 76. I'm just showing you these ordered pairs to satisfy the equation. Thus, they are solutions to this linear equation. Put negative 5 in for x real quick. Negative 5 times negative 2 times negative 5 is a positive 10. 10 minus 6 is 4. And look what you're supposed to get. A 4. 4 equals 4. Okay? So it does work. Now, let me finish off today's video by saying some things that need to be said. And the wise students will listen to me, and those that, well, I don't want to say unwise, those that are not making a good decision won't listen to me. This material I've taught you today is the complete and total foundation for when we start graphing linear equations. And that's what we're doing next, by the way. Okay? So I'm just telling, in fact, actually I made a mistake. I'm very sorry. For your lesson number here, you should have put lesson 4.2, part 1. Would you fix that real quick, please? Thank you. Lesson 4.2, part 1. Because really, the rest of lesson 4.2 is about graphing linear equations. And I'm going to tell you right now, if you cannot find a solution or 2 or 3 solutions to a linear equation, then you will not be able to graph the linear equations. So you need to understand this, okay? That's all for today. Don't hesitate to call me or email if you have any questions.